Viewers, you are watching Mathematics channel number Collage. In this video, we will study how to find eigenvectors when the eigenvalues are repeated. This question is about finding eigenvalues and eigenvectors of the matrix A. For finding eigenvalues, first we will write characteristic equation of this matrix, which is determinant this 6 minus lambda, this 3 minus lambda, this 3 minus lambda, where lambda is a constant. Rest of the elements remaining constant equals 0. After expanding and simplifying, we get 2 minus lambda into lambda minus 2 into lambda minus 8 equals 0, giving us lambda equals, that is, eigenvalues 2, 2 and 8. Here, two eigenvalues are repeated, each being 2. Now we will find eigenvector for this repeated eigenvalue lambda equals 2, for which we write the matrix equation A minus this 2 lambda into eigenvector x equals 0 vector. This we write as matrix 6 minus 2, 4, 3 minus 2, 1 and 3 minus 2, 1 again. The rest of the elements remaining the same. Eigenvector x1, x2, x3 equals 0 vector. Next we perform interchange of row 1 and row 2. Minus 2, 1, minus 1, 4, minus 2, 2, 2, minus 1, 1. Rest of the things remaining the same. Next we can make these two rows 0 by performing operations R2 plus 2R1 and R3 plus R1. So bottom two rows 0, first row remaining the same, and rest of the things. From this vector equation we get one equation minus 2x1 plus x2 minus x3 equals 0. Here we have converted the coefficient matrix into a row echelon form where there is one non-zero row, showing that the rank of the coefficient matrix is R equals 1 and the number of unknowns n is equal to 3, which shows there are 3 minus 2, 1 linearly independent solution. Now for finding eigenvector, we will rewrite this equation as 2x1 minus x2 plus x3 equals 0. Now in this equation we will put x3 equals 0, that will give x2 equals 2x1, and if x2 is 2, x1 will be 2 upon 2, 1. So the first eigenvector x1 that we get is 1, 2, 0. We have another option. If x2 is 0, x3 will be minus 2x1, and if x3 is 2, x1 will be minus 1. Or if x3 is minus 2, x1 will be 1. So the second eigenvector x2 will be 1, 0, minus 2. So corresponding to repeated eigenvalue 2, we get two linearly independent eigenvectors x1 and x2. Next we will find eigenvector corresponding to the eigenvalue lambda equals 8. Now let us write eigenvectors corresponding to repeated eigenvalue lambda equals 2. Here the first eigenvector 1, 2, 0 and the second 1, 0, minus 2. Now we will find eigenvector corresponding to eigenvalue 8. For that, first we write 8i into eigenvector equals 0 vector. So that will be matrix 6 minus 8 minus 2, 3 minus 8 minus 5, 3 minus 8 minus 5, the new diagonal elements, and rest of the elements remaining the same. The eigenvector x1, x2, x3 equals 0 vector. Now by R2 minus R1 and R3 plus R1, we will make these two elements 0 and write 0, 0 first row as it is. Now by R3 minus R2, the last row will become 0 and rest will remain unchanged. From this, we will get two equations: minus 2x1 minus 2x2 plus 2x3 equals 0, which is same as x1 plus x2 minus x3 equals 0, and secondly minus 3x2 minus 3x3 equals 0, same as x2 equals minus x3. Now if we put x3 equals 1, gives us x2 equals minus 1, and hence x1 2. Therefore for eigenvalue 8 we get a single eigenvector 2 minus 1 1. This question is also on repeated eigenvalues. Here we have to find the eigenvalues and eigenvectors of the matrix A. As usual, we will start by writing the characteristic equation. Determinant 3 minus lambda minus 3 minus lambda 7 minus lambda, the diagonal elements, rest of the elements remaining the same, equals 0. After expansion and simplification, we get lambda minus 3 into lambda minus 2 whole square equals 0, and hence the eigenvalues 3 and 2 repeated eigenvalues 2 and 2. We will find eigenvector for repeated eigenvalue lambda equals 2, for which we write matrix 3 minus 2 1 minus 3 minus 2 minus 5 7 minus 2 5, the diagonal elements, and rest of the elements remaining the same, into the eigenvector x1 x2 x3 equals 0 vector. Below I write down various steps required to make this coefficient matrix in a row echelon form, explanation of which is self-explanatory, or I have explained it at length in my previous videos. To save the time, I will write only the steps that you can check for yourself. And the last step, R3 minus R2, gives the row echelon form. In this row echelon form, there are two non-zero rows. Therefore, the rank of this matrix is 2. R equals 2 and the number of unknowns is 3. That is, n equals 3, which means there are 3 minus 2, 1, a linearly independent solution. From this last step, we can write two linear equations by matrix multiplication, which will be x1 plus 10x2 plus 5x3 equals 0, and 5x2 plus 2x3 equals 0. We will put x3 equals t, so that x2 becomes minus 2t upon 5, and hence from first equation x1 will become t. Now if we put t equals minus 5, x3 will be minus 5, x2 2, and hence x1 5. So we get eigenvector x1 corresponding to repeated eigenvalue 2 as 5 2 minus 5. Remember, here we have conveniently selected t equals minus 5 so that x1, x2 and x3, all three are integers. As we have many times discussed earlier, that any non-zero scalar multiple of eigenvector x1 is also an eigenvector corresponding to that eigenvalue. Next, we will find out eigenvector corresponding to eigenvalue lambda equals 3. So for lambda equals 3, we write first the diagonal elements 3 minus 3, 0, minus 3 minus 3, minus 6, 7 minus 3, 4. Rest of the elements remaining the same. Eigenvector x1, x2, x3 equals 0 vector. We will perform operations to convert this coefficient matrix into a row echelon form, and the steps we will write without explanation. Now from this row echelon form, we will write two equations by matrix multiplication. x1 plus 3x2 plus 2x3 equals 0, and 2x2 plus x3 equals 0, putting x3 equals t, we get x2 equals minus t upon 2 and x1 minus t upon 2. And if we put t equals minus 2 conveniently, then we will get x3 equals minus 2, x2 1 and x1 1 again. And the eigenvector corresponding to eigenvalue 3 is x2 equals 1 1 minus 2, and eigenvector corresponding to repeated eigenvalue 2. We have already found out the corresponding eigenvector x1 as 5 2 minus 5. Viewers, if you like this video, please like, share and subscribe this channel, Number Collage. See you in the next video. Until then, keep watching Number Collage. Thank you.